Hey everybody! So welcome to our first video lesson of the school year. We're back to it. I'm still in my room. You might have noticed I've got my like right there. I've got all the standards for calc. Like that's one of the main things I'm focused on this year because it's a new course for me. I also got new art behind me and all kinds of fun stuff. So excited to start another school year with you. This first unit is going to be done all asynchronously. So it's going to be what you want to work on at the pace that works for you. So if you want to get all these done in a day like a crazy person, you could. This one probably shouldn't take too long. I'm going to try to go a little fast, but also slow because it's our first lesson that we're doing together. So the first one is all about lines. This was like chapter 2 of pre-calculus. We just kind of skipped over it because it's a little bit boring. But we'll go over it for the purposes of this stuff. So you might remember our good old friend, the slope formula, y2 minus y1, x2 minus x1. And then right next to it, there's another way I want to talk about it. It's delta y and delta x. That little triangle thing is a delta. And what it means is change. And we're going to use that delta symbol a lot in calculus. So I thought I'd throw it in here. And it's just like the change of y and the change of x, delta y, delta x. So if we wanted to use this formula in a more interesting way than we've done in the past, one thing that we could do is we could try to figure out an x that's going to get us the slope that we're looking for. So we take our two y values. So we go 2 minus this negative 2. So I got this one and this one over the x values. But one of the x values I don't know. And we want this to end up being 2. Well, this is now an equation that we can choose to solve. So we're going to make this into a 4 over x plus 8 equals 2. And now we got to solve. I'm going to flip both sides of the equation. So we're going to make this one half. We're going to make this x plus 8 over 4. Multiply both sides by 4 and add 8. Let's see, so that's going to be 2. No, it's got to subtract 8. So multiply both sides by 4 is 2 minus 8, so we get negative 6. So that's the x value that they're looking for. Hey. Next one that we're going to look at is slope-intercept form, y equals mx plus b. It's our favorite, so it's real quick and simple. You can take your slope, that's your m value. Still don't know why they use m for slope. You can write negative 1x, probably easier, just write negative x. And then our b, our y-intercept, where it's crossing our y-axis, the up and down line, is 2. Oh, equals, what am I putting equals there for? Plus 2. And there's our slope. Now, one thing I forgot to mention is these. So I'm taking these out of our Finney book, and I'm going to do that a lot. Like I'm going to be pulling from the example set. So rather than writing down this whole problem, I should have said this on the first one, dang it. You just want to write on the little side just F-7-22. Finney, page 7, number 22. You can do the same thing on that last example. Rather than writing down the full thing, just Finney, page 8, number 38. That's going to help you keep up with these videos so then you don't have to write out the whole problem. You can just write the stuff that I'm writing and that little piece, Finney, page 8, number 38. And the reason that we say Finney is there's also the Larson book because we work out of 2 textbooks for calculus. So don't write the whole problem, just write the important like kind of little tidbits and then Finney F722 so that you don't have to write the whole problem out. So in this one, you would write down general form ax plus by equals c. And then to do the actual problem, you just write Finney 718. Got it? So we want to write a general equation for the line through the 2 points. So first thing I want to know is slope, because we've been doing slope. So let's take care of that first. So our slope of this thing is going to be 1 minus 1 over 2 minus 1. So that's 0 over 1. So my slope is just 0. So that's just one of those horizontal lines. So since my slope is 0, I know it's just going to have a y value. So I know A, in some sense, is going to be 0 because there's going to be no x term on this thing. It's never going to cross the x-axis. So it was like 0x plus, I don't know what B is, so I'm just going to leave it a B and a Y equals C. And so we know it's just going to like cross at 1. It's just going to stay at 1, and it's going to go over 1, up 1, over 2, up 1 when it's graphing all those points. So we know it's just going to be y equals 1. Y is just going to stay 1 the whole time because it has a slope of 0. It's just a flat line. There's other ways you could do this. You could also do a systems of equations. You could start with this and plug in the xy values that you got and solve for b and c. Be a little bit more complicated. You can use also your mathematical sense to figure this out. Here's another one. We want to identify, we're going to do this one a little different. We're going to identify our slope, our y-intercept, and we're going to graph that line. Remember, all we need to worry about writing down is that Finney 727. Finney, page 7, number 27. So to figure out this slope and the y-intercept, best way I know how to do it is I'm going to turn this into slope-intercept form because they're asking me for slope, they're asking me for y-intercept. Might as well get it in slope-intercept form. Boom, I'll have both those things. So I'm going to do a little solving. So I got 4y equals negative 3x plus 12. We're going to divide both sides by 4. Y is negative 3/4 x plus 3. Now that it's in slope-intercept form, it's really easy to spot what our slope and our intercept are. Our m, our slope, is negative 3/4, and our y-intercept is 3. So if we wanted to graph this, it's super easy, barely an inconvenience. We want to graph our y-intercept at 3, boop, and then we want to do our slope of down 3 over 4. So 1, 2, 3, 4. So from this point, I'm going to go down 1, 2, 3 over 1, 2, 3, 4, and then there would be my new point. We could do that in reverse as well if we wanted. We could go up 3 and then back 4 to get to there. And here's our cool line. Woo! It's super straight, right? I've got a little music in my ear, just so that I'm not talking to a completely empty room. I feel like I go crazy. I kept feeding back into the video when I was trying to get my setup going, but I don't know why. Now, our all-purpose one, the one that's not easy to graph, but it really helps us write equations, is point-slope form. You just take a point, plug it into the x1 and the y1, and you take a slope, plug it in for m, boom, you got yourself an equation. So in this one, right, remember on the side, you're just going to write F713. We've got our basic stuff. This y is always going to be a y. I'll leave a little space for my y1 and my m. We're going to take our point P, that's 1 and 1. We're going to put them into the x and the y spots. And then our slope is also 1. So then that's done. We've got a point slope equation for that line that goes through the point P and has a slope of m. That easy. Just a quick reminder, if you ever wanted to do horizontal and vertical lines, we did this a little bit earlier, but if it's just y equals some number and x equals some number is a vertical line. So if we had this point, the vertical line is going to go through the a, which is the x value. So that's just going to be x equals 2. That's for part A. And then for part B, you just take the y value and keep that thing constant. Y equals 3. So if you want to have a vertical line, you just take the x value. If you want to have a horizontal line, just take the y value and just keep it the same the whole time in both cases. All right. Next, parallel and perpendicular. So parallel lines, same slope. Perpendicular lines have opposite reciprocal slopes was the fancy word that we used for it. Really, you just flip it upside down and change the sign. So if we wanted to have an equation through P that is parallel to L and perpendicular to L, really, if it's parallel to L, we want to have the same slope as L. So here our M is going to be -1. We want to be perpendicular to L. We want to be opposite reciprocal of that thing. So we know it's going to be positive instead of negative because we're going to change that sign. And then we're going to flip it. But 1 over 1, when you flip it, it's still 1 over 1. So our slope is just going to be 1. Now it said write an equation and it's got to go through P, and P is at 0. So that is a y-intercept. So 0. So I can just use that to write my two equations. The B for both of these equations is going to be 0. So the first one, the parallel one, it would be y equals my slope, which is -1, so negative x, plus 0, but that seems a little silly to write plus 0, so it's just y equals -x. To do the perpendicular one, it's just y equals positive x. Done. Again, plus 0, but that'd be a little goofy. All right, now we're going to do a little calculator stuff, linear regression things. So we've got this annual compensation. This is especially one where it's really easy to just be able to write this, and then you can just worry about the things that are going on in the calculator. So we need to type this into our calculator. Mine's not loaded yet, so I got to get that loaded. Quick cut. Okay, so now I've got my graphing calculator loaded up. We're going to type these into our graphing calculator in order to create that linear regression. We could do this by ourselves if we did like the calculations that we were doing before, but I want to show you the calculator way of doing this too. So we're going to go into stat and we're going to edit our list. So we got L1 and L2. I'm going to use the regular numbers. You could adjust this so it's years since 1980. Oh, my earbud doesn't want to stay in my ear, so we'll just take that out. And we're going to type them into these two lists. So I got 1980, enter, and 1985, enter, and then and so on and so forth. So I'm just going to type all these in, try to cut that down on the video. Or no, we'll keep. Well, you can do it with me. If you want, you can fast forward, or you can just type them in with me. It's up to you. When we do this one, note don't do commas because that'll freak it out. Good. Got that typed all in. So now I'm ready to actually find the linear regression line. So it is in, I believe, stats. And then we're going to go over to calc. And we want the linear regression right here. So again, where I went was stat, then over to calc. And then we're going to choose linear regression. And I'm going to hit enter. Some calculators will ask you about, well, which list do you want to use? It's L1 and L2. But boom, there we go. There's our linear regression. Can I keep this? So that's not going to disappear on me. So our A is our slope. So our linear regression is y equals 1060.423 x plus, oh God, what is this number? 207,754.8.669. All right. Find the slope of the regression line. What's the slope? It's going to be that first number there. So that 1060.423. Now, if we wanted to actually graph this thing, we could type it into our graph. Now, one thing that you have probably heard me say lots and lots of times is the plot should not be highlighted. This is when we do want to turn that on so that we can see those points plotted on our graph. So I'm going to type in this number, 1060.423. And I think there's a way that you can like shortcut this, but who's got time for that? 207.7548.669. And let's graph. And I see nothing because my window's wrong. Take a look at your numbers. Where our years are from 1980 to 1990, and I'm definitely not looking at that. So let's have that be a part of our window. So our X values, let's go from 1970. Ooh, I got an extra 0 in there. Just so that it's not right up against the edge of the screen. And let's go to 2000. Why is my X scale so goofy? Let's go by tens for my X scale. Now my Y values, once again, look at how big those numbers are. We want to make sure that our window is inside of that. So let's start at 20,000 as our low end, and let's go to about 34,000. And let's have our scales be by 1,000. Let's graph that. Ooh, there we go. There's all of our nice points. And we don't have a line. Why don't we have a line? I was hoping that would be there too. Be right back while I fix it. Okay, I figured it out. I'm sure you are all yelling at the screen. Check it out. So let me quit out of here. There's a little negative. Did you spot this little negative? And then I wrote this positive. Oops. That should be a negative. My bad. So all I need to do is hop into here, and we're going to replace that plus with a minus. And then hopefully that'll look better. There we go. Oh, look at how well it goes through that thing. We still need to use the regression equation to figure out the construction workers' average annual income for the year 2000. So that is going to be especially exciting because we've typed it into our calculator. So I'm going to go to table set. So I pressed second window. And the independent variable, so you can set it to auto, so it just generates numbers for you, or you can set it to ask, and then you can put in whatever numbers you want. So if I go to my table now, where it's got that X value, the X value I want to put in is the year 2000. And then there's the average annual income, 43 to 97. And that's in dollars. All right, cool. So that is it for today. So I'm going to always end with a slide like this. This is the TLDR version of everything that we talked about today. So things that we talked about in this video were the slope formula, parallel and perpendicular lines, and then the different ways that you can look at the equation of a line. You can use slope-intercept form, you can use general form, you can use point-slope form, vertical and horizontal, all that jazz. So what you want to move on from this is there's a check for understanding. So you don't need to get that perfect. All you need to do on that one is try it out, see how well you understood the things that are in this video. There's going to be some goofy little things in there too. That's fine. You're big kids. You can handle that. But just see how well you've absorbed this information before you move on to actually practicing it and cementing it into your brain. That's the skill practice afterwards. So Thanks for watching. Bye-bye.